Hi there, everybody. I wanted to take a few minutes to talk about the Lewis neutralization panel. So when you get to page 9 in the Lewis module, there's a objective here about the characteristics of Lewis antibodies. Of course, every time we study a different blood group or group, we have a section on the antibodies and their characteristics. So it's a really important section. But I'm just going to focus down into a couple of things on page 9 of the Lewis module. One mentions that Lewis antibodies are more often found in the sera of pregnant women, which is really quite interesting. And people often will ask why. And I don't know if any of you have been, well, I know some of you have been pregnant. I know for me, I was like a balloon filled with water a lot of the time. Women's fluid volumes increase substantially when they're pregnant. And the antigens, the Lewis antigens that have glommed onto the cells, tend to fall back off into this excess amount of fluid that women that are pregnant tend to have. And so then what these women tend to do is form Lewis antibodies. And sure enough, they come in to have their baby, their antibody screen comes up positive, and then we're doing a panel to see what antibodies are present in their plasma. So what I've got for you to look at, in addition to reading the material here, is to print off on Bright Space this panel on Jane Doe. And you can find this under Lewis in the content on Bright Space. And I think it's called page 9 neutralization panel. So if you haven't got that with you right now, you might want to just pull that up and we'll just have a little bit of a chat about that. So what we're going to think about here is that this patient's plasma came up positive in the antibody screen. So the next step is to do a panel. So we've set up a panel. Now this panel has 11 cells. Oh, my room is waning here and my light's waning, but anyway. So this is an 11 cell panel. And so what we did is take 11 test tubes and label them correctly, put the patient's plasma in each of the test tubes, and then to each tube we added the applicable cell. Okay, so we have 11 tubes, all with 2 drops of patient's plasma. Tube 1 has cell 1 in it. Tube 2 has panel cell 2 in it. Then all of those tubes received PEG and were put in the incubator at 37 degrees for 15 minutes. And after that, we performed the same things that we would do with an antibody screen. So we wash times 3, we add 2 drops of anti-human globulin, spin, read, and record, and then add check cells to the negatives. So this panel is just like a big screen. Think of it that way. It's often the easiest way to think about it. So let's look at the reactions that we got for the panel when we ran it with PEG by IAT. So I've got 3 columns over here of patient results, and I just want you to look at this PEG IAT. You might not be able to read my writing there, but it's written sideways, and it says PEG IAT. Okay, so just look at this column, because when you run a panel, that's what you're running. I haven't done these 2 columns yet. I've only run the PEG IAT. And you can look at the results and see that I've got reactions in almost every tube of the 11 tubes. Okay, so I've got reactions 1 plus, 2 plus. Oh, there's a negative reaction. I've got another 1 plus, and I've got this 3 plus down here as well. This last tube, you don't really have to know too much about it right now, but what that is that's an auto control. So in this test tube is patient's plasma and patient's own cells, plus PEG taken through IAT. So this is an auto control. If that was positive, we would be concerned that the patient has an auto antibody. And what we would do next would be a DAT to see what is coding the cells. But when we look at a panel, one of the first things we look for is that auto control. Oh, it's negative. Great. This isn't an auto antibody. I'm going to start thinking about what antibody is present, antibody or antibodies are present in the patient's plasma. When a patient reacts with almost every cell, it's very hard to see a pattern of reactivity. So it causes us to wonder how we're going to figure this out, to tell you the truth. So the first thing that I would do if I had these results show up, especially in my hospital where I worked, because at the Peter Lougheed Center, it was a pretty big maternity hospital, and we had a lot of pregnant and delivering women there. So my thought immediately, but it might not be your thought immediately because you're all new to this, would be that, oh my gosh, I bet you this lady's produced some Lewis antibodies. Now, the biggest clue in this set of reactions is this negative reaction. Negative reactions often give us the best clue. And so if my hunch is correct that this person has produced some Lewis antibodies, this should make sense. So no reaction of the patient's plasma with a cell that doesn't have Lewis A or Lewis B on it. So basically, that little piece of information there is what got me thinking this patient has produced an anti-Lewis A and an anti-Lewis B. If you look at every other cell, it has one or the other on it, either the Lewis A or the Lewis B. So at this point, just a hunch. I look up here to the patient's information. Sure enough, it is a female. Sure enough, she is in for a C-section. So obviously she's pregnant. And a bit of information that she was transfused 2 years ago. This is important information for me because this lady is pregnant. So there's a baby in there. And if she was transfused 2 years ago, it is possible that she has produced an antibody, and possibly that antibody's titer has increased during the pregnancy, and the baby could be affected. So we definitely need to find out what the heck these antibodies are. If they're just Lewis antibodies, you will learn as you work through the module, Lewis antibodies are really not something that causes hemolytic disease as a newborn. These antibodies are not involved in hemolytic transfusion reactions. So Lewis antibodies are a pain in the butt, but they're not clinically significant typically. So let's get rid of them. Let's go with the hunch and get rid of the Lewis antibodies. To do that, you add to the patient's plasma, not in this tube, but another test tube with patient plasma in it, you add neutralizing substance. So this is called Lewis neutralizing substance, and it's made up of soluble Lewis antigens. So you add that to the patient's plasma that apparently contains the anti-Lewis A and the anti-Lewis B, and those antibodies will bind to these soluble Lewis antigens in the neutralizing substance, and these antibodies will be neutralized. They'll be bound to the soluble antigen and they will no longer be able to react with panel cells. So we set up the panel again with the neutralized plasma. So let's look at the next column in the results. So at the top here, it says neutralized plasma. Okay, so this is the plasma in which the neutralizing substance was added, and now we take a look at the reactions. Well, the first thing that I notice is that I still have some reactions. So I'm concerned then that there is another antibody in the patient's plasma. I also notice that I've lost a lot of reactions. So my hunch was right that the patient's plasma probably contained some Lewis antibodies that I was able to neutralize. So now in the neutralized plasma, I do have a lot of negatives and some positives, and it's easier once you have more negatives to see some sort of pattern. So what I mean by pattern is that I have a negative, 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 positive, positive, negative, 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 positive. Is that pattern what would be expected of any particular antibody in this patient's plasma? So we look over at the columns underneath each of the antigens. So let's look at D. So under the D, we have a negative. This cell, panel cell 1, does not have the D antigen, but panel cells 2, 3, and 4 do. So if the patient's plasma contained an anti-D, I would expect that the patient's plasma would not react with the first cell, would with the second, would with the third, would with the fourth, would not with 5 through 9, and then would react with 10 and 11. This pattern, 0 plus 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 0 0 0 0 0 plus plus, is not the same as what I'm seeing here. So take a sec and look through the various columns and see if you can see what this pattern of reactivity now matches. So what I've said in the guided lesson plan is that this pattern matches what we would expect if the patient's plasma contained an anti-K. So if we look down this big K column, we have a bunch of negative reactions. We have cells 6 and 7, which have the KEL antigen on them, cells 8 and 9 and 10 that don't, and cell 11 that does have the K antigen on. Notice that those reactions mimic what we're seeing here, so that the patient's plasma is only reacting now with KEL positive cells, the big K positive cells. What this is saying to me is that the patient's plasma contained Lewis antibodies, and it also contains an anti-K. Am I concerned about the Lewis antibodies? Not at all. Am I concerned about the anti-big K? Definitely. Anti-big K is typically IgG. It's reacting with IAT at 37 degrees Celsius, so I'm expecting it is an IgG antibody. IgGs can cross the placenta, and IgGs could potentially harm this baby if the baby's KEL positive. So yes, I'm very concerned about this anti-K, so I'm pretty happy that I had this hunch and neutralized the Lewis antibodies. The last column on this page is the dilution control. And as lab techs tend to do, we worry. And what we worry about is when we created this neutralized plasma, we took patient's plasma and added some drops of the neutralizing substance. And the thought was, well, maybe just adding drops of something else has not neutralized, but rather just diluted out that original antibody. So a dilution control is just that. It controls for the dilution that was used to make the neutralized plasma. So again, we would need a bunch more free plasma from the patient, and we would add, instead of the neutralizing substance, we would just add saline to that in the same proportions as we would add the neutralizing substance to a vat of plasma as well. So this is just a dilution control. And these results should be very, very similar to our original results. Okay, so just dilute it out a little bit. So the important thing that we've found here is that the patient's plasma contains an anti-KEL. Okay, and the hard thing for students sometimes to grasp is this concept of the pattern of reactivity. Remember, these are tubes 1 through 11. They each had neutralized patient's plasma in it, but these tubes, 6, 7, and 11, still reacted with the panel cells, and sure enough, cells 6, 7, and 11 have the K antigen on them. We would still have a little bit of work to do on this panel to make sure that there's nothing else present, and do what we call ruling out and a variety of other little tests, but we'll leave it at that for now because we haven't covered antibody ID. If you have questions about this, please post on the discussion board or send me an email. The sticking points, like I said, is kind of the decision to originally neutralize the Lewis, just on a hunch, and then the other sticking point for students is trying to figure out where I'm coming from. Why do I think there's an anti-K there? Now, once I've made these decisions that the patient has an anti-Lewis A, anti-Lewis B, and an anti-K, I'm going to look back at these original reactions and see if that makes sense. So the patient's plasma was put in a tube and I got a 1+ reaction with panel cell 1. That cell has Lewis B on it. It doesn't have Lewis A on it, and it doesn't have the K antigen on it. So I'm thinking that the patient's plasma is reacting with Lewis B and giving us a 1+ reaction. Okay, now here I've got a 2+ reaction of the patient's plasma with panel cell 2. This cell is positive for Lewis A, it's negative for Kell. So I'm thinking, okay, well, the anti-Lewis A in the patient's plasma is reacting about 2+. Let's see if this pattern continues. Here I've got a 1+ reaction with panel cell 3. It has Lewis B on it and no Kell. Oh, okay, that's similar to my first cell. And sure enough, it's reacting 1+. Panel cell 4 did not react at all. It does not have Lewis on it. It does not have Kell on it. Panel cell 5 reacted 2+. Okay, oh, interesting. It has Lewis A on it, no K. And again, I feel like the anti-Lewis A is reacting about 2+. So I do look that over in the end to see if these strengths of reactions make sense. Probably one of the more interesting reactions that I'm seeing is this one here, this 3+ reaction. So sure enough, that cell is positive for Lewis A, which was, reacting about 2+, and positive for Kell, which was reacting about 1+. So that makes sense. So I do always look back through these reactions and make sure that they make some sort of sense to me after I've made my decisions about what's present in the patient's plasma. I hope this helps. Like I said, please post your questions and feel free to send me an email.